So what's up? What else do the treehouse detectives need to know about space? How will humans overcome the harshness of space for travel to Mars? How will robots help lead the way to Mars? All this and more when the NASA SCI Files continues.
Don't forget to look for the answers to the following questions. What are galactic cosmic rays? Explain how spacecraft will be self-healing in the future. Why does NASA need new propulsion systems?
Captain Houston, how do you read this?
Roger, Houston. We're at Mach 10.5 and everything looks okay. Guys, I'm reviewing protocols for an upcoming mission. It's so cool because you work directly with mission control to troubleshoot and solve problems throughout the entire mission simulation. Right now I'm reviewing re-entry and landing procedures after successfully launching a new satellite to track RJ's exercise program. The counselors monitor your progress closely, and they even introduce problems into the mission simulation for the teams to solve. You really have to be prepared. Keep up the good work, RJ. Over and out.
Kind of goes against the whole idea of working out, doesn't it?
No, that's the beauty. No fat frozen yogurt with sugarless sauce and toppings, and it even has fresh fruit. It's totally healthy.
I'll just stick with the water.
I have to admit, Bianca's right. Ever since we started exercising, I feel great.
We're not quite ready to go into space, but we're getting there.
Dr. D's comments on the potential dangers of space travel do have me a little concerned.
Me too. I've been going over all our research, and the radiation problem seems critical.
So what do we do next?
Time for the problem board. We know that space is an extreme environment.
And NASA trains astronauts to live safely in that environment.
And astronauts will also need to learn to live on the moon and Mars.
So what do we need to know?
We need to know more about how astronauts will deal with radiation in space. Catherine mentioned in her report that she might be able to meet with Mr. Mark Wayland at the NASA Johnson Space Center to learn more about radiation.
Good idea.
We might even be able to learn how to send a treehouse detective to Mars.
Excellent idea. Wait, what, send someone to Mars? Are you crazy?
I'm fine. Corinne is going to stop by the Mars Society's remote habitat in Utah. It actually simulates what working and living will be like on Mars.
That is really cool.
Where are you going? Up to see Dr. D?
No, Dr. D isn't home. I'm going to get another banana split.
You're kidding.
No, when you eat the light version, sometimes you have to eat twice as much to fill up.
You'll never learn.
Mr. Weiland.
Hi, Catherine. I'm glad you could stop by. I understand you want to learn more about radiation in space.
Yes, we've read that radiation is very dangerous, but we're not exactly sure what it is.
Well, radiation is one of the top biological concerns for our astronauts. There's two basic types of radiation, light and particles.
How is light dangerous?
Light comes in many different forms. The low-energy visible light that you're familiar with isn't dangerous, but light comes in a high-energy form called ultraviolet.
Isn't that what causes sunburn?
Well, that's right. X-rays and gamma rays are another form of light with more energy than ultraviolet, and they can cause serious damage to your body's cells.
What about the particles?
Very fast-moving particles are considered to be radiation. One example is high-energy protons, which are released by flares on the sun. Another even more dangerous type of radiation are galactic cosmic rays, or GCRs.
What's a galactic cosmic ray?
GCRs are extremely fast-moving protons and nuclei of elements such as iron, silicon, and other elements that come from outside our solar system.
Why are they so dangerous?
They can penetrate more than 100 centimeters into materials and can cause a lot of cell damage. They are also very difficult to shield against, and they can even create additional radiation when they collide with metal spacecraft.
Wow. I've heard that radiation can increase your chances of getting cancer. Is that true?
That's correct. The greater the radiation exposure, the greater the risk of getting cancer and other effects such as cataracts, which is a clouding of the eye lens.
What determines how much exposure you get?
The length of the mission is one of the most important factors. A mission to Mars could take several years. Longer missions mean greater health risk from radiation exposure, especially compared to space shuttle missions, which are much shorter. However, NASA is working hard to reduce the risk.
What are they doing?
They're developing better shielding materials that will prevent the radiation from reaching the astronauts in the spacecraft. And high exposures can also come from very intense events, like solar flares.
Isn't that when the sun has a solar storm?
Very good. If you can monitor the sun for solar storms that produce these flares, then you can warn the astronauts to avoid spacewalks and to enter specially shielded storm shelters in their spacecraft.
Is there anything that can help the body handle the effects of radiation exposure?
Well, NASA is looking at how a healthy lifestyle, including dietary vitamin supplements, might provide protection. They're also looking at the role that age, gender, and/or genetic factors play in how the body responds to radiation.
Wow. If radiation is such a problem for astronauts, why don't we have to worry about it on Earth?
We do have some radiation on Earth, but we're protected from most of it by something the astronauts don't have, an atmosphere.
Yes, I learned in my science class that an ozone layer of our atmosphere blocks a lot of the ultraviolet light from getting to Earth.
Well, that's correct, and it also absorbs a lot of X-rays, gamma rays, and high-energy particles. Charged particles, like cosmic rays and protons from the sun, are deflected by Earth's magnetic field, and Earth itself acts like a big shield.
I'm glad that we have some protection. Radiation sounds pretty serious.
Yes, it is. So don't forget, you should always wear sunscreen when you're working or playing outside.
Don't worry, I will. Thanks, Mr. Ryland. You've been a big help.
You're welcome, Catherine, and good luck.
Hi, guys. It looks like you've been working hard on the unmanned missions.
Along with research, we've been working with LEGO to build possible Mars explorers.
Cool.
Of course, we read all of your reports on the internet.
Having access to the internet is a wonderful thing. Speaking of the internet, you can always find great tools for research on the NASA SCI Files website.
Are you ready to go to the next level?
What do you mean?
Well, we've been working on different aspects of space travel, but there's one area that we haven't explored.
Like what?
Dr. Herb Waite from the University of California, Santa Barbara, just sent us an email.
Doesn't he research bio-inspired nanotechnology?
Right. He referred us to Miss Dana Novak. She's helping him in his research. Here she is now.
Hi, you must be the Treehouse Detectives. Dr. Waite said you would call. How can I help you?
We are researching space technology to learn more about the future of space exploration.
What does bio-inspired mean?
Well, it simply refers to any technology inspired by biology. For example, when George Demestrel took his dog for a walk one day, he saw that they both had burrs stuck to them. He looked at a burr under a microscope and saw hooks and loops. That inspired him to invent Velcro.
What a great invention. I use Velcro all the time.
What plants or animals do you look at for inspiration?
Right now, we're investigating mussel threads and bloodworm and clamworm jaws.
Mussels, clamworms, and bloodworms? Sounds interesting, but why exactly are you interested in worm jaws and mussels?
If we're going to explore the moon, Mars, and beyond, then we need new, advanced, and self-healing materials for spacecraft construction.
What do you mean by self-healing?
Think about what happens when you accidentally cut yourself. It's amazing to watch how quickly your body acts to mend the wound. Like this model, we're trying to understand how to give composite materials those same qualities. This model demonstrates how two different types of bonds within a material work together to self-heal.
And why is that important?
One weakness of current composite materials is that they tend to form tiny hairline cracks, which can lead to major damage over time. In long-distance space exploration, repairs won't be easy.
Right. There won't be a spare parts store you can stop at while in space.
Nope, there won't. However, with new high-performance materials, such as the self-healing materials, we will be taking the first step in building spacecraft capable of traveling millions of miles from Earth that can fix themselves.
That's awesome. But I still don't understand what mussels and worm jaws have to do with it.
Nature specializes in how to put materials together in the most effective and efficient ways. We look at the mussel threads because they're very strong, yet thin and lightweight.
It's amazing how much we can learn just by looking at nature.
We can learn how to make materials that recover quickly from stress. Think about when you buy a six-pack of soda. When you take a can out of the plastic loop, the plastic stretches but is difficult to break. Nature inflicts damage on the mussel threads just like you do on the plastic. We call this damage creep, and it is undesirable. However, in nature, many materials that experience creep recover from it, and we're studying the mussel threads to learn how.
What about the blood and clamworm jaws?
The jaws appear to be just as resistant to abrasion as the tiles on the space shuttle, yet they have only half the weight per equal volume.
We learned in the case of the challenging flight that weight is a very important factor. The lighter the airplane or spacecraft, the less fuel it needs.
That's right, and we hope to learn not only how to make very lightweight spacecraft materials, but also tougher ones.
Why do the materials need to be tougher?
The materials used for spacecraft are subjected to enormous stress, so it's crucial that they be tough as well as self-healing.
Sounds like this research is exciting. Thanks, Miss Novak.
You're welcome. Keep up the investigation and call me back if you have any other questions. Bye.
That was impressive. Never thought that studying mussels and worms could help us learn about traveling through space.
But I'm still trying to figure out how we're going to do it. I mean, what will our future space vehicles look like?
I'm not sure. Maybe Bianca can help us.
Well, she's been training down at Space Camp, but I don't think their program includes future spacecraft.
No, but they are close to NASA Marshall Space Flight Center. I emailed her last night. She wrote back and said she was meeting with Mr. Cook.
Way to go, Catherine. Have you heard from Dr. D yet?
No, wasn't he working with you and Tony?
Well, we talked to him a couple days ago, but we haven't heard from him.
Maybe Bianca gave him a new fitness program to work on too.
Well, if so, maybe we should call his house. He may need some help.
electrical propulsion work? You can't have an extension cord in space.
No, it uses electrical energy from a solar array to accelerate a propellant. There are three types of electric propulsion systems: electrothermal, which uses electrical heat; electromagnetic, which creates thrust using a magnetic field; and electrostatic, which uses charged particles in an electric field.
Don't we currently use chemical rockets?
Yes, and they have been the primary means for transportation in space because of the very large amounts of thrust they generate that are needed to overcome Earth's gravity. As fuels become more advanced, chemical propulsion will continue to play a vital role in space transportation.
They all sound great, but isn't one propulsion system better than the other?
Well, there are pros and cons to each system. The choice of propulsion system depends on the energy requirements of the mission, its duration and destination, and whether it is robotic or human.
I can't wait to travel through space. It's so exciting.
Yes, it is. So keep studying your math and science.
Don't worry, I will.
Oh, by the way, Dr. D called. He said he wanted to meet you over at the Neutral Buoyancy Laboratory.
Dr. D at space camp? That's strange. Well, it is Dr. D.
Attach stabilizer into position on both the array and above auxiliary power panel and lock into place.
Roger.
Fully deploy array by rotating handle counterclockwise.
Roger.
Dr. D, is that you?
You bet. I'm training for a spacewalk working on this underwater solar array.
Of course. We learned from Dr. Utley in the case of the inhabitable habitat that astronauts learn to work in the weightlessness of space by diving into a huge tank of water called the Neutral Buoyancy Laboratory.
That's correct. It takes a lot of practice to prepare for space travel.
That's what I love about Space Camp. We get to practice, they emphasize the importance of teamwork, and of course I'm looking forward to the simulators.
Simulators are great. They allow you to experience what space is really like. Let's go check them out.
This is the space shot.
Great! It simulates liftoff.
Doesn't liftoff make astronauts feel heavy?
We'll see. times the force of gravity, just like the Apollo astronauts at liftoff.
Can we do it again?
Sure. 3, 2, 1.
Dr. D, I also felt weightless for a few seconds at the top.
It was because you were freely falling. It's not quite free fall, but if you go to the moon, you will only weigh 1/6 of what you do on the Earth.
That's a great weight loss program.
Let's see how you do, weighing only slightly more than 2 gallons of milk. Buzz Aldrin said that galloping like a horse was easier than jogging. Well, why don't you try the bunny hop? Awesome.
Training like this before going to the moon is a great idea.
Now that you've experienced walking on the moon, you need to train for re-entry into the Earth's atmosphere. This is the multi-axis trainer, and trainers like this were used by our country's first astronauts in the Mercury program to prepare for the possibility of a tumble spin during re-entry.
Oh, I almost forgot. You've got to contact the other treehouse detectives. They don't know where you are.
Well, that's right. I didn't tell them. I'll get on it right away, just after I become disoriented. Dear treehouse detectives, sorry about the quick departure. I had some important work to do at Space Camp. I saw Bianca. I'm sure she will fill you in. Looking good. Maybe just a little longer is all I can handle.
So what's up? Will Bianca survive the rigors of training? Who will be the next generation of explorers to go to Mars? Would you like to walk on Mars someday? Stay tuned for the exciting conclusion of The Case of the Great Space Exploration.